Good afternoon, welcome to another tutorial by Mprofita. Now we use the exact equations. I want to solve the ordinary differential equations using the exact differential equations. Now an exact differential equation is exact if it can be written in the form m of xy dx plus n of xy dy equal to 0. Now we say this equation is exact if there exists a function f at xy such that df equals to m dx plus n dy. So df over dx should be equal to m, and df over dy should be equal to n. That's it in a summary. So let's take an example. Another important condition that we must consider is the following condition: dm over dy should be equal to dn over dx before we take an example. Now I'm going to take in an example. The first thing that I'm going to do is to show that this function is exact, and then I'm going to solve it using this particular method. Let's find dm over dy. So you need to know how to solve partial differential equations. So this function, the derivative of let's identify m and n first. M is equals to 3x squared y squared, n is equals to 2xy cubed. So dm over dy is 6x squared y, dn over dx. Now let's differentiate this partial derivative with respect to x. So 2 times 3 is 6x squared y. So that's our derivative right there. So this means that this holds, and because it holds, we can use this particular method. Now if this holds, we know that df over dx should be equal to m. What is our m? 3x squared y squared. And df over dy should be equal to 2x y, using the following definition there. So from there we pick any of these two. I usually prefer to work with x. I didn't fight with my ex-girlfriends. I'm in good terms with them, so that's why I usually prefer working with x. 3x squared y squared dx. So from there we introduce a partial derivative both sides. We use integral. So the integral of this is simply f at x y. Integrate this with respect to x. 3x cubed y squared over 3 plus g of y. Remember, if you're dealing with this, your constant should be in terms of y, and if you're dealing with this, your constant should be in terms of x. F at xy is going to be x cubed y squared g y. Now let's differentiate this with respect to y, so that we can find this. The f over dy is going to be 2x cubed y plus gy. Now if you look at df over dy, there it's df over dy is equal to 2x cubed y, 2x cubed y plus gy. Now if you take these to the left hand side, we'll be left with we'll be left with 0 equals to g prime y. Where's g prime y coming from? Sorry, whenever I start differentiating this with respect to y, this should be g prime of y. Sorry for that. dg over dy equals to 0, dg equals to 0 dy. Integrate both sides, so g of y equals to, what is the integral of 0? Is simply a constant, so that tells you that you f at x y equal to x cubed y squared plus some constant c. Thank you for watching my video. Don't forget to subscribe, share and like. Thank you very much.